Determine the number of solutions of each system of linear equations by inspection. If they have the same slope and the same y-intercept, they are going to be the same line and have infinite solutions. But if they have the same slope and different y-intercepts, they will be parallel and have no solution. With different slopes, they'll intersect at one spot. So let's look at problem 4. If I were to change this into slope-intercept form, I'm going to start by moving the 8x over. Then I'll divide by 2 on both sides, and that gives me y equals 4x plus 3. So they have the same slopes, but different y-intercepts, which means they are parallel and have no solution. For problems 1 through 5, indicate the method that you would use to solve the system of equations. Now for this first one, since they're both written in slope-intercept form, I might choose to graph those and see where the points intersect. But for the second one, since it's already solved for x, I might use substitution to replace 4y in the x position. Here, this one is solved for y, so I would substitute all of this in for y. This one has a 3y, so I can replace all of this with 3y. This one is written in standard form where the x pieces are stacked, so I might use elimination for that one. In class, this will be done as a gallery walk, where one group will be responsible for completing one problem and displaying their work for their classmates. But on the digital lesson, we're just going to use our workbook space to answer the 5 questions. So I have the grid here that I can use to solve problem 1. Problem 1 had the equation y equals -1/2 x minus 8 and y equals -1/2 x plus 4. If I were to distribute here, this equation would turn into y equals -1/2 x. Half of 8 is 4, and a negative times a negative is a positive. So I already know that it's going to have infinite solutions because they have the same slope and the same y-intercept. But let's graph those lines just to be sure. We have a positive 4 as our y-intercept, and the slope tells us to go down 1 and right 2. And then we'll connect those using a straight line. This would also start at 4 and go down 1 right 2, so it's the same line for infinite solutions. For number 2, we said we were going to use substitution, so I'm replacing x with 4y. Half of 4y is 2y. Move the 2y over with the other y. Y minus 2y is negative y. Divide by -1. Y equals -3. Then we will plug it back into the original equation to solve it for x. 4 times -3 is -12. And don't forget to write your answer as coordinates. So the x value, then the y value. For number 3, we said we would use substitution here as well. This is all going to replace y. We'll distribute 3x. Negative 2 times a fourth is negative a half. X. Negative 2 times positive 2 is negative 4. We can combine like terms here. That would give us 2.5x minus 4 equals 6. Add 4 to both sides. 2.5x equals 10. Divide by 2.5. And that is x equals 4. Then we need to plug it back in to solve for y. Replace the x with the 4. The fourth of 4 is 1. And 1 plus 2 is 3. So the coordinates of our solution are 4, 3. In problem 4, we will be using substitution again. 3y is going to get replaced with negative 2x plus 6. We'll start with some distribution here. Negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. We can combine like terms. 6 minus 3 is 3. We can add 2x to both sides. That leaves us with 3 equals negative 2, which is not a true number sentence, so this has no solution. Well, let's look at question 5. On the slides, my equation said this, but in the teacher's edition and in the workbook, it has 2x plus 5y equals 10 instead. So we're going to use the addition that's in the students' books. Now I can make the y's be opposites by multiplying this top equation by negative 2. Because 10 is 5 times 2, so to make it an opposite, 5 times negative 2 would be negative 10. But we're going to do the whole thing multiplied by negative 2. So 2 times negative 2 is negative 4. 5 times negative 2 is negative 10. And 10 times negative 2 is negative 20. Then we'll use our second equation. And we are eliminating the y terms. Negative 4x and 3x make a negative x. 10 and negative 10 make 0. Negative 20 and positive 30 make 10. We'll want to divide both sides by negative 1 to get x equals negative 10. And then we need to substitute it back into one of the original equations to solve it for y. 2 times negative 10 plus 5y equals 10. That would give us negative 20 plus 5y equals 10. Add the 20 to both sides. 10 plus 20 is 30. Divide by 5 on both sides and we get y equals 6. So the coordinates of our solution is negative 10, 6. So we were able to see a graphing example, a substitution example, and an elimination example all in today's lesson based on the various types of equations and how they were written. You may have solved these using a different strategy, but you should still arrive at the same answer.